Hello friends, I am very much delighted to announce this Pandas tutorial series. Pandas is a popular open source Python data analysis tool. Pandas is primarily used to analyze structured data which is in the form of tables. It is very widely used tool for data processing because it is very powerful, works efficiently and very easy to use. If you have installed Python via Anaconda framework, Pandas will be installed along with it. I would highly recommend to install Python via Anaconda as it installs lots of dependent libraries along with Python, which includes Pandas as well. Very popular integrated development environment for Python like Spider, Jupyter Notebook and PyCharm are all coming as part of Anaconda framework. So when you install Anaconda, you are all done. In the description, I'll include the link of how to install Python via Anaconda framework so that you can get Pandas along with it. And I'll also include the link of how to install Pandas individually. For this tutorial, I am going to use the CSV file. I have downloaded this from the internet and this is a mocked up data. So this has the employee details of a particular company, and basically these has the fields as you can see, like the employee ID, first name, middle name, last name, gender, date of birth, age, etc. So as you can see in the salary column, there are two rows where the salary is not having any value or it is null. So we are going to use this further and see how we can use Pandas to process this data. Now I have opened up a new Python 3 notebook in Jupyter. In the first line here, I am importing Pandas as PD and I am going to just read the CSV file that we just saw now into DF, which is the short form of data frame. So once I read it, data frame should be having the entire data which was present in the CSV file. Just to see the first few rows in Pandas, I can use df.head. And when I run this, you can see that the first 5 rows from that CSV file is displayed here, and you can see the null value in the salary on row number 3 is displayed as NaN, which is not a number in Pandas. And you can also see that Pandas has automatically indexed the rows from 0 till the total number of rows. So this indexing and binding automatically happens in Pandas. If you wanted to see the last few rows, then you can use the command df.tail. So here you can see the last 5 rows. If I wanted to know more technical details about this data frame, I can use df.info. So here, as you can see, this is of type data frame and it has totally 20 entries indexed from 0 to 19. And these are the details of the columns. It has the column name and it also has the data type of each of the columns. So it says that employee ID is integer and first name, middle name, last name are all mentioned as object, which is nothing but strings, and the age is of float data type, and date of joining is of object data type or string data type. Experience and salary are of float data type. So here you can see that date of birth and date of joining are taken by default as string data type, and this can be modified so that it is considered as date data type. I can also get some statistics around this data. In order to do that, I will have to use df.describe. The output for describe gives the stats for the columns which are having numbers. So here employee ID, age, experience and salary these were having numbers, and we can see the stats around those columns. If you take for example age, the total number of rows with values were 20, and the average age is 42.15, the standard deviation is 13.05, minimum age is 21.1, maximum age is 59.47, and these 25, 50 and 75 percentage, these are all percentiles. Same for experience, employee ID and salary. So if you can see, the count of salary is 18, but for the other columns the count is 20. This was because basically two rows were not having salary values in the data that we have already seen. Now I can also use df.shape to get the shape of this data frame. Here you can see it is 20, 10, which means that there are 20 rows and 10 columns in this. If I have to select any specific column within this data frame, then probably I can just give the column name. So here I just wanted to see only the first name. So when I run this, I can just get the first name column from this data frame. I can also get the shape of this particular subset of data frame. So here I am just getting 20 because this is just having 20 rows. One another thing that I can do here is actually get the data type of this. So in order to get that, I am going to just use this, and when I run, then I just get the data type of the first name, which is a series. So in Pandas, all the columns are considered as a one-dimensional array, and this is a series in Pandas, and the data frame is two-dimensional array. I can also pull more than one columns by explicitly mentioning the column name. Here I am interested in the first name and the salary, so I am just mentioning those column names. And here I just get the first name and the salary column alone. I can also give the specific column index to pull the columns that I need, or the row index to pull the row that I need. So for that I am just using df.ilog, and in the command, this is of the syntax row comma column. So here in the row I just wanted to have from index 2 to 5, and in the columns I just want all the columns. So I am just giving a hyphen over there, and if I run this, I am just getting all the columns, but I am just getting the rows with index 2, 3 and 4. I can also filter the columns that I need. Here I am just giving df.iloc, and in the rows I am just retaining this 2 to 5, and for the columns I just want 0 to 3. So when I just run this, I just get the employee ID, which is in index 0, first name and the middle initial. So it just gives from 0 to 2. So here this 5 and this 3, these are excluding these specific indexes, as you can see from the result above and below. I can also create a smaller data frame or a subset of the parent data frame. So here I just wanted to create a smaller data frame which has few columns, and here I am just giving first name, age, experience, salary, and I am just assigning it to another variable called subset. So when I run this, this command has executed, or this line has executed, and now I can see that only these particular columns which I have selected has been stored in the subset. Now I wanted to create another subset which is not having any null values in it. So here salary column is having two null values. I wanted to filter out those rows and I wanted to have only the rows which is having value for all the columns. So in order to do that, I am just selecting the salary and I am giving dot not NA. So this actually selects only the rows which are having values in the salary column. And from where do we need to select? We need to select it from the subset, and here I am just going to assign it to not null subset. So when I run this has got executed, and I can just see how it looks like. So here I am seeing all the values, or I am not seeing the rows which are not having NA in salary. So we have got this. I can also just visualize the data. In order to do that, there is a function called plot. So I am just using that plot function. Here I can visualize the data. In the y-axis there seems to be the salary number, and in the x-axis it seems to be experience number, but I can also just explicitly mention what I want to see in the x and the y axis. So here I am just going to use a scatter plot. So plot dot scatter, and in the x I am going to use experience, and in the y I am going to use salary. And when I run this, I can see that the x column is having the experience and the y column is having the salary, and these blue dots are the people who are having the corresponding experience and salaries. So one another thing I want is, I just have the age and this is in years. So I just wanted to include one more column to see the age in months. In order to do that, I can use the assign. So here we have this not null subset, and I am just using dot assign, and here within that assign I am going to use the column name age in months. This is the column name that I am going to add, and here I am just selecting the age column and I am going to multiply it by 12. So I am just executing this. It was giving error and now it is resolved. The mistake that I made was that I had used not null subset with incorrect case. So now it is resolved, and here you can see that a new column age in month is assigned, and it is actually having the value of the age multiplied by 12 for each of these rows. Now I am happy with this data frame. It has all the columns that I need, and I have also eliminated the rows that were having null. So I just wanted to share this information to my friends, so I wanted to just store it in Excel. In order to do that, I can just use dot null subset dot to underscore Excel, and as parameters I can give the Excel name. Here I am going to give employee info dot xlss, and I can also mention the sheet underscore name. Here sheet underscore name, I am mentioning it as maybe M, and I am just executing this line. Let me just check if the Excel has been created. Here I see that employee info is created. I am just opening this Excel, and I can see that it has all the rows and it has only the columns that I had selected. But one thing is, here I am able to see the index of each of the rows, and I don't want to see that index. So what I am going to do is, I will close this and I will go ahead here. I will delete this Excel. I am going to come back to this particular line, and I am going to give index equal to false. So now when I run it again, this creates the Excel again, and if I open the Excel, I am not able to see the index. So this was the example of some of the basics things that we could do with Pandas, and in the upcoming videos we'll be getting more deeper into each of these functionalities and much more. I'm going to store this code in my GitHub link, and I'm going to just refer this link or include the link in the description of this video. If you like this video, please subscribe to my channel. I will be posting more videos related to machine learning and deep learning. Thank you very much.